is our very last official class of the semester. Crazy, right?
Oh my god.
It seems like it went by super fast. So Monday is optional. It's just going to be a review session. And then I'm giving you no class on Tuesday.
Oh.
Just relax and prepare for the exam, Good? Oh, okay. Today what we're going to do is we're going to review chapters 10 and 11 a little bit. And then we're going to kind of go over chapters 4, 5, and 6 because I feel like those are ones that people forget and struggle with, right? Because it's been long enough that we've forgotten, and it's hard enough that you kind of have to sort them out a little bit. Today, don't forget, you have Connect Math 11.1 due today, and remember, it's going to have things in different orders. So it's going to give you like your expected values. It'll give you like your dolphins, seals, penguins, otters for your expecteds, and then for your observed, it'll give you them in different order, like otters, dolphins, seals, penguins, right? And so you got to make sure you line those up, or else you'll go crazy and it'll drive you nuts. So be aware of that. Again, as we talked about before, exam 4 is rolled into the final, and we're going to start our exam at 5. Even though the official starting time is 5:30, if we start at 5, I can give you extra time, and I can give you that extra 25 minutes instead of only having an hour and 50 minutes. You can have 2 hours and 15 minutes. So we're going to start at 5 o'clock here. Again, like I said, Monday is just going to be review. It's optional. So if you feel totally comfortable and confident and you want to spend your time on your other classes or life or whatever, then feel free to do that. Andrea and I will be here on Monday going over things. Okay. Yeah.
And same rules, we can come at 1:30 or 7:30.
Yeah, oh, for the exam? Yes. But if you're not coming at 5, email me because I do have a limit due to COVID as to how many people can be in the room at one time. So email me and it's first come, first serve. Right? Yeah.
Is there going to be a magic trick?
Today.
Oh, okay.
So remind me today, I forgot to show the 2 p.m. class. I feel really bad after they left. I'm like, oh, because it is the best one. So I think during the review session on Monday I'll have to show them, but it won't be quite, or I can show them before the final, but I mean, that's a little, right? Let's stress you out before, I don't know. Yeah. Maybe I should relax. It might be relaxing, but it might drive them crazy because they'll be like, how does she do that? And then they're going to forget about their...
Yeah. They're going to be thinking about it the whole time. Like, oh, that's
all right.
Great.
For the final, again, it covers chapters 1 through 11. No new handouts today. You can have 1 page of notes, 8.5 by 11, both sides, or your 4 half sheets, either one. Try to use your half sheets. They would still have their little half sheets from chapters, exam 1, 2, and 3. So try to use those today as we're going through problems, because that will be, what you'll have on the exam, on the final. You also get your yellow sheet, the magic formula sheet, obviously your tables, and bring your binder so you can get extra credit, and your TI-8384 calculator. You've all seen this the last several classes. There it is again. So you guys have final. And then you also saw this, right? These are the claims you're going to have for HNOT for your homework. The claims, if any of these are your claims, that's your HNOT claims. If any of these ones over here on the right are your claims, that's your H1 claims. And then remember, you might want to take note of this. So for the exam, because you folks should all be making sort of a magic formula sheet of your own for chapters 10 and 11, right, for exam 4. So some things you might want to put down there are, for chapter 10, for step 5, you're going to say, either you do or do not have enough evidence to support the claim that there's a correlation between blank and blank, whatever your 2 variables are. If your claim is, if you're doing 11.1 or 11.2, a chi-square test, then for step 5, your step 5 is going to be, you do or do not have enough evidence to reject the claim that proportions are as expected. That's it. You just use that generically. And if for ANOVA, step 5 should be there is or is not enough evidence to, again, reject the claim that the means are the same. So I would suggest, again, you sort of make this sort of maybe, formula sheet, and maybe you have your linear regression. And write down everything you need to know about that. So what are some things you need to know? Well, you need to know what H naught is, right? You also need to know how to find your critical value. You also need to know that you should use lin-reg t-test of L1 and L2, so you know it's lists and it's not something else. You might want to remember that you have this is how you draw the picture, right? It's not something different. You might want to write in what your step 5 is. Right? You might want to comment on if you reject H naught. If you reject H naught, is it a line or not a line? It's a line. Because if you do not reject H naught, it is not a line, right? Not. And then if it is a line, then you'll use y equals a plus bx to predict. If it's not a line, then you'll use y equals y bar to predict y, or x equals x bar to predict x. Right? So that's what you might do for linear. You might do something like that, and then you'll do some for chi-squared. You'll have some stuff for chi-squared, for the line. Maybe how do you figure out what your expected value is? For chi-squared matrix, again, how do you find the first and last expected values, that sort of thing. So you should kind of put in your different things you have to do for these, and then ANOVA. So you should kind of have kind of all of your stuff sort of settle out into something clean and clear. And then back again to, remember, it's super important you know how to tell a problem apart, because I guarantee you there will be people on the exam who will take a linear correlation problem and they'll do a chi-square test with it. And they do that and you just take in 10 to 15 points and flush them down the toilet, right? I mean, it's a larger exam, it's a 200-point exam, but still you've flushed away that many points. So it's really important you know what kind of problem it is. So one way of knowing is if you have two things you know about each sample, like each person. If they're numbers, like their height and their weight, then that's linear regression. Right? If the two things you know about every person are categories, like their gender and their favorite flavor of ice cream, then that's two things you know about them. That's going to be a chi-squared matrix. If you only know one thing about them, like their favorite soda flavor, that's a chi-squared list. If you only know one thing about them and it's a number, like their miles per gallon was the easiest one to do, but that's ANOVA. Sometimes you know two things. You know what category they're in and what their number is, because there's 3 different lists, right? One for each category. Like, I don't know if you guys remember that problem. There was like small cars, and there was sedans, and there was SUVs. That was one of the problems we did. Okay. Another comment on this one is the chi-squareds. Remember, these are frequencies and proportions. They're going to be categories. So you have categories, and you'll have frequencies or proportions in them. And it occurred to me Tuesday night that I should probably talk a little bit about this part here. If I can either have a frequency, if I have a proportion, I need to give you, either I give you a percentage, I give you a p hat, right? I give you a percentage, or I give you x, the number of successes, and you have to find p hat. How do you find p hat? X over n, right? You have to find the percentage yourself. So these proportions always have those two sorts of things. They always have a percentage or a fraction, and they have the actual number of people. And they're related because, like you said, p is equal to x over n, Or I might give you, if you're trying to find what x is equal to n times p. You folks remember that? These are equivalent. Getting some nods is good. So remember, the frequencies, those are like x's. Whereas the proportions or the percentages, proportions are the fractions, right? Fractions. Or the percentages are kind of like your p-hats. So you have to remember that. So let me show you these two problems that we had last time. This one here. Here, the observed are whole numbers. Those are my x's. How many people say yes? Right? It's x. It's not a percentage. But okay, so maybe I should ask you this: what kind of problem is this? Let me take a look. What kind of problem is it? Step back a little bit. Should I flip to the other one? Hold on. We'll flip back to this. Right. So remember, if it's lists with categories only along the top or the side, not both, then that's what we call kind of lists. So this one is your, if you have 3 or more lists, ANOVA. If you'll have 2 lists and then matched up in pairs, that's the linear correlation. This one here, where you have categories here on the side and the top, that's your chi-squared list. And then here you have categories here and here. If these categories are observed and expected,
I thought that was matrix.
yeah, I'm sorry, you're correct. Thank you. Apparently having trouble talking. That's chi-squared matrix. If you have observed and expected along the sides, or if you have this, where you're just given that, you're only given the categories, these can't be lists because there's only one item in them, right? This is a list where you have lots of items. If you only had one item, that's not a list, that's just a number. Does everyone see the difference? I got categories across top, but those are not 3 lists because there's only one item in each. Can't have only one item in a list. So these are lists because they got multiple items in them. That's just 3 categories and the observed values in each category. All right, so that's how you know that that's a chi-squared, and because it's on a matrix, it's a chi-squared list. Thank you for fixing that for me, before I confuse people too much. So now we're going back to this problem over here. And I'm going to ask you, what kind of problem is this? Chi-squared list. Remember we did this last class? These were our categories. Everyone remember this from last class?
Yes.
Okay, you don't, but everyone else does. These are our observed, our actuals, our observed. These are our expected. However, these are not. So again, we should be comparing. We always have the idea of there are proportions or percentages, right? And there are x's, kind of actual how many people said yes. So here, 20 people said yes. I should not be comparing an x to a percentage or a proportion to 2/15. I should find out how many people said yes. So how many people do I expect to say yes? So 20 people said yes. How many people do I expect said yes? Well, 2/16 of what? Of the total. So I would like everybody to find, here I'll tell you what I've got here. This equals 103 total. But does everyone see how here, if I can't compare these two numbers because the top number, those are number of people who said yes, actual people. And the one below is a percentage, right? So if I said, well, 8 people in the class got A's, should I compare that to 13% or 15%? You know what I mean? Like, you should compare them to how many people you expect. If I expected half of you to get, if I expected 10% of people to get A's, then it should be 10% of the class, right? 10% of 30. Does everyone understand what I'm saying? So I shouldn't be comparing 8 people to 0.1. I should be comparing them to 0.1 of the whole class. All right, so everybody find the expected values here. Take a couple minutes with your neighbors, find them. So another quick comment is, remember your observes are from your sample. Your expecteds are kind of like your alpha. They're what you expect to get. So they have nothing to do with each other. Your observes and your expected are two separate things. What comes first? So here's the problem. Well, okay. So I'm thinking about World Series games, and what do you think comes first? What you expect to get, or what you got from your sample? Yeah, you figure out what you expect to get. I think there's going to be, 20% this, 30% that, 40% that, 10% that, and then you take a sample. Does that make sense? So your expecteds can never depend upon your observes because you find the expecteds first. But you figure out what you expect to get, and then you take a sample and figure out what you observe. So you never use your observes to compute your expecteds ever. The expecteds come first. So if I sample 103 people, how many do I expect to have 4 games? Yeah, 2/16 of 103 of them. Means multiply, you said that's what? 12.875. How many expected to have 5 games? 4/16 of 103. 25.75. And then 5/16 of 103. Is everyone understanding where these are coming from?
Yeah.
Right? Okay, good. So that's good enough. Here's another problem that you folks did do. Maybe. Here we go.
Oh, yeah.
Does everyone remember these ones? All right, so we had Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. We had our observed, we had our expected. And they gave us our observed. And I think the total equaled 1,095.
Yeah, that sounds right.
Okay. How do I figure out how many I expect? Well, are these x's or are these percentages? Or proportions, fractions?
X's.
Those are x's. So I should be comparing them with actual numbers, people. How many people do I expect? Not what percent do I expect, but how many people do I expect? So if I have 1,095 people altogether, and I didn't give, if there is no percentage, if I didn't give you a percentage in each group, then you should be looking to see if they're all the same, if the proportions are expected to be the same. So what do you think? Or no difference in the proportions. So what do you think? What does it say? Everyone read what the expectation is. Claim, what's the claim? Claim is different days of the week have the same frequencies. What does that mean? That they're all equal. All the frequencies are equal. That's what we expect them to be. We expect all these numbers to be the same, all my expecteds. So what should they be? 1 each? 10% each? What?
156.4.
How do you find that? You take 1,095 and you distribute them equally amongst all of them. Right, so everybody find the first expected value. Do it. Find it. Find it without looking on your previous sheet. Find it new if you didn't do it, if you know, not from last time. Destiny, what'd you get?
156.42.
How'd you find it?
So I got the total, which is 1,095, and I divided it by 7.
Because there's 7 of them. Good. So you divide it, there's 7 categories, you split this equally amongst the 7. Okay, good. So you'll need to know how to do that for the exam. Why I'm bringing that up. Okay. So back to telling these problems apart. If you don't know how to do that, we went through it like a fair amount last class and the class before. We went through a bunch of examples. I feel like people are tired of looking through examples of that. So I'm not going to subject everybody to that. But if you're still having trouble with that, then you need to practice it, because again, you'll lose a lot of points on the exam if you do the wrong thing. If you try to put a square peg into a round hole, you're going to lose all the points on the round hole problem, right? So the last 2 pages of the Not a Study Guide are just problems for you to identify what kind of problem it is. There are chapters 7, 8, and 9 mixed in here. So it's all of them mixed in there. And I strongly recommend that if you're having trouble telling them apart, that you go through this and you try to figure out what kind of problem it is. And I believe the answers are posted on Canvas. If not, email me and I can post them. All right. This is just like an exam question. Do not talk to anybody else, because you cannot cheat. You can't ask other people on the exam. Everyone take 30 seconds and figure out what numbers go where here. There's numbers across the top. Right, 3 numbers across the top and 3 along the bottom. Or sorry, 4 along the top and 3 along the bottom. Okay, which one's 100? None of them. Correlation is only between -1 and +1. So those are all not possible. Which one's +1? Third one on the top. Which one's -1? The one right below it. Which one's 0? Far right, over here. And then these 2 will be some positive number that's a fraction. These 2 will be some negative number that's a fraction. Everybody on board with that part? Okay. That's good enough. All right, so did we finish this one? Did we actually go over the problem? Or not?
No, we didn't.
Okay, so let's take 2 more minutes and let people finish this one up and answer the questions A, B, and C, and then we'll go over it.